gain twin, and that's why I need a factor. 3 does factor out, which makes your life a whole lot easier. Okay. -1, and then what do I do with that?
Side part.
So we left -1, -2, so I get negative times negative, which is a yeah. I thought we put it into no derivative, into the derivative. All of this term is in the derivative.
-5.
Wait, I thought you just put it -2.
Negative
X squared minus 6. You can plug it in there if you want to. Okay, so plug it in there. Oh, you're plugging it to 12.
Plus 12.
Now, let me show you how quick I did it and how I would choose. You can totally plug it in up there. It takes you a minute, doesn't it?
I just got confused. When I did 12 minus 12.
And there's a lot of room for error, and it takes you a minute, right? Is this completely equivalent to that? And so -2 minus 3 gives you a negative number. And -2 plus 1 gives you a negative number. And a negative times a negative is 5. But you can do it however you like. Let's make this many shortcuts as possible. Aren't you? Zero. Plug in 0. A negative times 5. 4. 5 to 5. But you could plug it into that unfactored form if you want. Just any questions so far? So first of all, let's ask for the intervals of increasing and decreasing. Where is it increasing? With a sign chart, that's a very easy answer, isn't it? Yes. Pull it off the sign chart. And decreasing from -1 to 3. Any questions about that? Relative extrema, right? Find the extrema. Well, at -1, we have a maximum. Now, I showed you a great way to write those yesterday. Y'all are okay, so I'm going to just write this one as a point. How would I find the y value, though? Go back to the original equation and plug in -1. -1 cubed is -1. -3 is -4. Plus 9 is 5. Plus 1 is 6. Yes? Plug -1 into the original. And that is a relative max. Relative min is at 3. Let's find out what that is. 3 cubed is 27. 27 minus 27. Everyone agree? 0 there. Minus 27, so -27 plus 1 is -26. So that's my relative. Now this doesn't ask this question, but we're going to start thinking about absolute extrema today. Does this function have an absolute extrema? Why not? Right, if I draw it, not anywhere close, but isn't this one of these? So it has no absolute minimum and it has no absolute maximum. So it only has relative.
So here are 2 points on the end, and then with the -1, 6 be the absolute maximum.
It depends.
If it's an even function.
Does that mean no cubic or
No cubics from -infinity to infinity would have an absolute. Now, if we only looked at this at a certain window, then it might have an absolute on it, and so we'll talk about that in just a second. So, just wanted to throw that out there. Okay, critical number. I'm going to skip number 1. We're good. first derivative test to find extrema. I do want to do these two. Skip the first one. I think you could do fine. I want to do these two because they're a little yuckier. I'm recording.
I know, I was like, I figured you paused it instead of like leaving the video going for like several minutes. That was very
What was it? Oh, critical points, increasing and decreasing, and finding the maxes and mins using the first derivative test. Okay, so what am I going to do first for all of those things? What is it?
2/3 x plus 2.
Very good. Any questions about that so far? Times 1, but we don't need to write it, but just to keep remembering. Now, normally I'd let you leave it that way, but to find when it equals 0 and when it might be undefined, I'm going to need to rewrite it. What is a negative 1/3 power? Cube root on the bottom. So this is really 2 over 3 cube roots of x plus 2. So now I have a fraction. When do fractions equal 0? When the top is 0. When is 2 equal to 0? It's not. So this doesn't equal 0. But we have critical points. Also could happen at undefined places. Is the denominator ever 0? Where at? Why at negative 2? Does everyone agree? Negative 2 makes the denominator 0. Okay. So that's my critical value. So here's a critical value. It's not technically a point because I don't have a y value. I could find it if I wanted to.
So anything that makes the denominator equal 0 is critical value.
Or the numerator. Denominator equals 0, derivative is undefined. Numerator equals 0, the derivative is 0. Hold on, just a listen. Harrison, does anyone know where Harrison is?
I haven't vexed it.
I think it's in PE.
Numbers.
Yeah.
Was it the other room next hour?
Okay.
Okay, so that's a critical value. Now, how do I find intervals of increasing and decreasing? I already did that. That's where I got the negative 2, the 0, and the 5.
So what we did on the last one, you just set that equals 0.
I already did that. Sign chart. Remember we said it doesn't equal 0, right? Because 2 doesn't equal 0, but it is undefined at negative 2, and we're going to put both of those on our sign chart. Remember in algebra 2, we even labeled this as an undefined point. You don't have to do that, but you could. You could mental note the derivative doesn't exist there. It's not a 0, but it is still a place your sign could change because it's a value where the derivative is not. We're going to pick a point less than negative 2, like negative 3. Negative 3 plus 2 is negative 1. A cube root of a negative is still negative, so I get a negative. Something bigger than negative 2? 0 plus 2 is positive, and everything's positive, so I am decreasing and then increasing. So my intervals of increase are from negative 2 to infinity, and decreasing from negative infinity to negative 2. There is not a relative maximum.
Why don't you use brackets on it?
Good question. Actually, AP would take either one always on intervals of increasing and decreasing because there's actually quite the controversy in the mathematical world on whether you're increasing or decreasing at that break point. I think that's a waste of time to discuss that. But to me, you can't be both increasing and decreasing at negative 2. And so I was,
Therefore, it's not going to be either one.
so I think it's parenthesis. Like I said, mathematical world, there's big debate on that. So, but to me,
They're doing something that
So it's what's big deal. Like I could tell you that it's not increasing.
I agree with you, but there's some very smart mathematicians, a lot smarter than me, that disagree with me. So, but I do agree with you. So I would just use parentheses on increasing. Okay. Is there a relative extrema?
Yes.
Where? At -2, there is a relative minimum, correct? What is the y value? How will I find it?
Plug it into the original.
Plug it into the original, I get -2, 0. So that is my relative minimum. This function, just for fun, so you'll know, if you were to graph it, looks like this. It's got a sharp corner at 0, 0. Sorry, at -2, 0, 5. This function looks like that. It's got a sharp corner at -2, 0. And that's why you have that undefined derivative there. But it is still a relative minimum, so we still want to include it. There is no absolute maximum because it keeps increasing left and right. There is an absolute minimum, isn't there? -2, 0 is actually also an absolute maximum. So again, just starting to think about those thoughts. We haven't actually asked that question yet, but I just wanted to start thinking about it. Okay, piecewise functions are a little strange. The reason they're strange is because what do you know about the derivative at the break point on a piecewise function? At the place where a piecewise switches from one piece to another, what do you know about the derivative there very often? Often does not exist because often you meet at a sharp corner, right? Now there are times it exists, we'll have to check that out, but very often you're going to want to consider that breakpoint as a possible critical value. I'm going to walk through this one really slow. I'm going to graph it and do some derivative testing and things like that so that we can kind of see what's going on here. Before I do anything, I'm going to graph it. You will get to a place where you don't have to do this, but it is good practice for piecewise graphing. This graph looks like 4 minus x squared when x is less than 0. So on the left-hand side, I'm going to graph that. And what does that graph look like? A graph moved up 4 units and flipped. So it looks like that. What does the other one look like? Slope of -2 through the origin, right?
It's opened off to
What's the y-intercept? So looking at this, you'd agree I have a relative max at 0. Right? I agree. But it's a strange one, isn't it? Is a knowledge of this graph important for being able to find critical values in increasing and decreasing? Yes. Now, I can answer all of the questions without doing any derivatives. Do we agree? With a graphic knowledge. It's increasing from -infinity to 0. And 0 to infinity. When is it decreasing?
from zero to negative.
It doesn't, does it? Increases and increases. Right? Everyone agree? From left to right, if we read this, I'm going up. I stop. I go up again. Right? So I'm always increasing. We have that weird jump in there, which is a little tricky, right? Any questions so far? And there are kind of two options on that 0, 4 point. if we were to do a derivative sign chart, f prime of x is a piecewise function. It equals negative 2x when x is less than 0. Everyone agree? Why not? What's the derivative at that breakpoint? Isn't it undefined? So I'm not going to define it here because it's and negative 2 when x is greater than 0.
So every time you do the derivative of it, you just take away 2.
Are these derivatives the same at 0? What's the derivative of this one at 0? 0, right? 0 times negative 2, 0. What's the derivative of this one at 0? Negative 2, right?
If you took the derivative of negative 2 is in.
But this is the derivative.
Okay.
So at 0, those derivatives are not the same. So would you agree that means that at 0 I have a critical point? Everyone agree? You also would look at each individual graph and set those equal to 0. Well, it turns out that one equals 0 is 0. Nothing fancy about that, right? So, not a critical point. Or it is a critical point at 0, but not that. Plugging a number less than 0, where would I plug that in at? The derivative. And which part of the derivative? If I'm less than 0. The less than 0 part, right? So if I plug in negative 1 into negative 2 times negative 1, I get a. And what about to the right? Oh, let me do that. What did I do?
You forgot to do the negative 2, so.
Now we're going to let me do that. I was trying to figure out so hard why it was increased. From the graph, it totally was. But y'all let me graph a line.
We thought you knew this.
And now it's in calculus.
Sorry. Oh, yes, you can. If you see me graph a line, you can totally. No. I don't know if you ever accepted me. Okay, any questions so far? Sorry. So increasing and then decreasing. Would we call 0 a relative maximum? Based on the chart. We would. We do have to be careful. Now on this one it's fine, it is greater than all the things around it. But here's what to be careful about. Could this line have started up here and had a negative slope? And then would it be greater than all the things around it? It wouldn't, would it? Because it would be up there. So you always want to have a picture in your head. This problem actually would take it whether you called 0 a relative maximum or not. They would take it if you said no, and there's some reasons they would take it if you said no because of the discontinuity. They would also take it if you said yes because it is the topmost point in that area. So be careful on piecewise is what I want you to know. The moral of this story is be careful. Have your algebra 2 knowledge in your head when you're working on piecewise because they're strange.
How would you put the maximum? Like how would you write down what the maximum is if it was a hole above like the
Then it wouldn't, because then it wouldn't be a relative maximum. So if this line had started up here and then this, then there would not be a relative maximum there.
not
Because
right there, but like what would you call it?
nothing. You would say it's neither a relative.
Zero maximum, it's just that.
No, because you never get to that. You never get to that point.
Yeah, but you get to right under it. It's a line.
So you get to point 5.9. But then Clay says I get to 5.9999. And then Morgan says, no, I get to 5.99. It's not. There is not a maximum if you have an algebra.
So because there's not an open dot there, you have a maximum.
You can put one down.
Because it's no.
Because it's a total. But be careful, because if it's open dot, it's not a maximum. Because you don't get there. You know what I mean by that? Tricky, piece by tricky. Okay, now let's talk about absolute extreme. Let's look on down the list, there'll probably be more. Wait. Elizabeth Jackson. Anyone know who she is?
Didn't she dropped?
Yeah. Okay. F of x equals x squared on -2, 5. I want to find the absolute extreme. From the first day we talked about extrema, look back at your little chart. Where could absolute extrema happen at? Let's read that. Where could absolute extrema happen at? The little chart that had the summary.
Was it critical points?
It could happen at critical points. It could happen at endpoints. I picked an easy one first. I've got a more complicated one here. How many of you know what this looks like? And you could probably all tell me where the relative min and the absolute min are and all of that fun stuff, just because you know what the graph looks like, right? So we're going to look at this one and see how calculus can find the relative extrema, but then take that to find absolute extrema. We know it could be at a critical point. So step one, if you're finding an absolute extrema, is find relative extrema. Right? So step one, do what we did on the last slide. So let's do that first. So I get 2x, and then I'm going to set that equal to 0. Where does that equal 0 at? At 0. So I'm going to do a sign chart. Except I'm going to block my sign chart off, and I'm going to stop at -2 on the left and at 5 on the right. Why am I stopping it? That's what it does, right? It stops at those points. I'm going to plug in a number between -2 and 0, and I get -1. So I'm going to negative. I'm going to plug in a number from 0 to 5, and I get a positive. So no question about it, you could probably tell without doing any work that 0 is an absolute minimum, right? Because it's increasing to the right, decreasing on the left, so it's probably tell that. But to find absolute extreme, use what's called a candidate's test. We have 3 candidates for an absolute maximum and for an absolute minimum. If there's an actually there is guaranteed to be an absolute min and an absolute max because of the extreme diagram. We have a continuous function and a closed interval, right? So we know we're going to get an absolute max and min. It either happens at -2, 0, or 5. Both of them. Does everyone agree? It either happens at a critical point or an endpoint. And in fact, you wouldn't have even had to do the sign chart to figure that out. You did have to find the 0. You had to find the critical point. But what we're going to do from there is very non-calculus-y. We're going to plug them in and see which one's the biggest. And we're going to plug them in and see which one's the smallest. The biggest one's the absolute max, the smallest one's the absolute min. These are the candidates, so it's called a candidate's test. Here are 3 candidates for an absolute extrema here. So we're going to plug them in and see which one works.
Are you doing this into the original? Or
into the original. And why into the original? Because what am I trying to find here? I want to find out which one is the tallest point on the graph, right? So I want to know. So I'm going to plug in -2 and I get 4. I plug in 0 and I get, and I plug in 5 and I get. So what is the absolute maximum?
5.
25. What is the absolute minimum? absolute minimum is 0 at x equals 0.
Oh.
So I have an absolute max of 25 at x equals 5. Absolute min of 0 at x equals 0. So moral of the story. To find absolute extrema, we find critical points and endpoints. Plug them into the original, see which one's the biggest, that's the absolute max, see which one's the smallest, that's the absolute min. If you don't have endpoints, then you would look at the limit as x approaches infinity, the limit as x approaches negative infinity, and consider those when determining absolute max and min. What you really just need to know is, do you go up forever? And if you do go up forever, is there an absolute max? No, if you're always increasing on the ends, there's not an absolute max. So the only time there's an absolute min or max is on a function that has a top point or a bottom point. You could find that out from the sign chart. It would be helpful. Most of the time when you're asked to find an absolute maximum, you are given endpoints. Almost always, you're given endpoints. And so let's look at one that's just a little tougher calculus-wise. I think an easy one on the first one, just to walk through the rules. Okay. The derivative's a little tougher in Greek. And does that ever equal 0? No. It is undefined at 2 o'clock.
Yes.
Where am I trying to find the absolute maximum at? Between 0 and 3. Is negative 1 between 0 and 3? No, so I don't care. So what does that mean? My only two options for a relative max at min are 0 and 3. Does everyone see how that works? So if you do not have a critical point, then your endpoints are probably your relative max and your relative min. If we were to draw a sign chart on this, right, negative 1 falls to the left, 0 and 3 are over here. And you could do, find out if it's increasing or decreasing between 0 and 2, 0 and 3, and it's always increasing, right? If it's always increasing, then isn't that going to be the relative min, or the absolute min, and that's going to be the absolute max? So it makes sense. So sometimes endpoints are your only option. How do I actually find it? I do a candidate test. And my only two candidates are f of 0 and f of 3. Plug in 0, I get natural log of 1. What is the natural log of 1? Who said that? Very good. Without the algebra, to look into that. You did. You learned it out. You learned natural log of 0 is 0. That is. No, natural log of 1 is 0. Natural log of 0 is undefined. And I don't know the natural log of 4, right? So I'm just going to call it, if I'm without a calculator, I'm just going to call it natural log of 4.
Probably.
It is bigger than 0. And you probably know that based on a logarithm graph, and natural log of 4 is a value greater than 0. So this is my absolute min, and this is my absolute max. Any questions about this? So that is how you do absolute extreme. A couple random questions that I want to start thinking about is sketching the graph of the derivative based on the original function. So I want to plot f prime of x. I don't know what f of x is, but I want to plot f prime of x. That's the first thing you know about f prime. It is the slope. So what do you know about it? It is linear because it's quadratic, so that seems reasonable. When is it 0? At the relative minimum, right? Which is the absolute. So you agree the derivative 0 right there? What is the derivative here? Positive or negative? negative, and it gets to a really steady negative. So do you agree the derivative would look something like that?
So why did you just find where the derivative would
Be zero, positive, and negative. It's mainly what you'll be looking at for right now. You'll get better and better as you go. This gives you the graph of f prime. So this is the graph of f prime. Use the graph of f prime to identify the intervals where f is increasing, decreasing, and estimate the x values of the relative maximums or minimums. I'm going to draw a sign chart. You'll get to a place where you don't need one, but for now, I'm new at this, so I'm going to draw a sign chart. And on that sign chart, I'm doing f prime. I need to know when is f prime 0. Well, what is f prime? It is, and what's that graph? That's already f prime, isn't it? So where is it 0?
no
2 and 8. Why 2 and 8?
what's the graph? I don't know that it was
It says use the graph of f prime. So I had to tell you that. If this is f prime, most of the time it will tell you the ones, so they're not going to try to trick you on which graph it is, but you just need to read. But this is the graph of f prime. So 2 and 8 are my critical values. Does everyone agree? That this is f prime. Left of 2, what is f prime? Negative. Everyone agree? It's below the x-axis. What about in between 2 and 8? What about after 8? So I identify the intervals of increasing and decreasing. And x values of the relative maximum. Why did they not ask y values? I don't have an original equation. I can't find them. I cannot find y values, but I can find the x values of the relative extrema. At x equals 2, what do I have? Everyone agree? And at x equals 8, what do I have? You try next. Still, this is the graph of f prime.
So this is the next equation, we have to find y values.
No, because that's the equation for y prime. So we won't learn how to do that until anyway. Sign chart for f prime. Again, there will be a time when you won't need a sign chart. You can just look at that graph and figure it out. But for now, let's do a sign chart to help us out. This is f prime, right? So let's go with f prime. Where are the critical values? If I did have the original graph, you agree those would look like maximums and minimums, right? But the derivative looks like a 0. Before -3, we are negative. In between -3 and 1. Okay, so I'm decreasing, increasing, decreasing, increasing. So my intervals of decrease are from -infinity to -3, -1 to 2. My intervals of increase are from I'm not looking at the garage.
-3 to -1 and to infinity.
oh it's backwards because it's
Oh, is that not? This is the derivative. And relative extrema doesn't minimums, when did those happen? What are the X value of the relative minimums? Minimum?
Oh,
Line -3. Decreasing and then increasing. Is that the only one? That is supposed to. Is there any way to know which one of those is lower? I don't have an original function, do I? So I can't plug anything in. All I know is where the relative minimum values happen. Relative maximum happens at questions. Okay, this is your homework. Everything's backed up one day. So the due Fridays or due Mondays, the due Thursdays, due Friday. I showed you this yesterday.
Yep.
Same stuff. I don't think it's been changed. Except I actually handed you the packet that I told you about. You can do everything on this. Tomorrow's a work day. But come in tomorrow ready to ask questions. I also am okay tomorrow on the work day if you need to take a mastery exam. If you just want to do this for homework and use that time for mastery exam if that's